Alright, so what we're going to do right now is demo the independent samples hypothesis test process. We're going to talk about a few of the things that you'll want to get as far as completing your project. So hopefully you'll use the videos we have from before for doing things like histograms, but we'll revisit descriptive statistics as well as how to perform the t-test in Excel for your assignment. So here I have a set of data that looks like what you guys have been given, a simple set of data separated into two columns. One says morning and one says afternoon. And what I have is basically test scores from students that are hypothetical for students that are in a class that's during the morning and in a class during the afternoon. They completed the exact same exam. Their scores were recorded. And now I want to compare these two to see whether or not there are differences in exam scores as a function of time of day. So the first thing I need to do is figure out my hypotheses. So for the hypotheses, we're going to have, of course, two versions. The first one to start with really is the alternate. So the alternate hypothesis in almost all cases is what the researcher expects. It's the research hypothesis. So the only reason I would be testing these two realistically is because I think there might be differences between the groups. So my hypothesis might be something like the average test performance will not be equal in the morning and afternoon courses. The null hypothesis then would say that that's not true. So what it would say is the average test performance will be equal in the morning and afternoon courses. So like the little video you guys watched, the null hypothesis generally is going to contain the statement of equality. Now we could have directional hypotheses versus non-directional, which you'll learn about this week with one-tailed and two-tailed tests. A one-tailed test is where you only look at one side of the distribution. So you only care if someone is extremely higher or extremely lower. You do not care if they're just different. So you notice I worded these in terms of just difference and equality. So I'm saying, you know, the two groups are going to be different. No, the two groups won't be different. Alternate and null, respectively. Now I could say something like students in the afternoon will score significantly higher in average exam scores than students in the morning. Now that would be a directional hypothesis. I'm saying the afternoon students will be above, so I'm looking for higher scores. Often in statistics, even when we have a directional hypothesis, we still will use a non-directional test. And the reason is that these tend to be more conservative. So you still have to meet a higher, threshold of proof, basically, if you use non-directional hypotheses. And then you'll still have significant effects even if you happen to get it the wrong way. What if morning, in fact, scored higher than afternoon? If my hypothesis was directional in a one-tailed test with afternoon being higher, but the afternoon scored significantly lower, I would just retain the null. Whereas if I did a non-directional test, then I would identify and reject the null hypothesis, even if the morning group was the group that was higher, not the afternoon group. So typically, we will use statements that are, the statements themselves might be worded in directional ways, but we'll use tests that are non-directional. So that is two-tailed. Two-tailed tests are the default in statistics unless otherwise specified. So what are we going to do now with the independent sample test? We've got our hypotheses. If we were going to write these out in more of, the terms of statistics, forgive me because in Excel I don't have all of the abilities to use the appropriate Greek letters. We can go through how to do that in Word. But I might say something like H naught. And H naught here would be that mu1 equals mu2. I could also word this for H naught as mu1 minus mu2 equals 0. And basically there you see the 0 because the hypothesis is that they do not differ. So no difference is represented by a 0 difference between these two. The alternate, on the other hand, HA, right, the research hypothesis, would be that mu1 does not equal mu2. Okay, or we could say that HA, we could say that mu1 minus mu2 does not equal 0. So the difference between them is a non-zero number. That is, it is significantly different from 0. We would conclude that there are likely real differences between morning and afternoon groups. So now how do we go about performing some of these important tests? The first thing I'd say we should do is get descriptive statistics. So we're going to go to data and to data analysis. Under data analysis, we're going to have the options that we need. I say first, let's start with descriptive statistics. So we can get our descriptive statistics for each of our two groups. So we can get them for morning. And we're going to put this output here on our same sheet with the summary statistics. And this is going to be for the morning group. So I'm going to relabel this morning. And then next to that, let's get descriptive statistics for the evening group, or the afternoon group. So we go back to data analysis, descriptive statistics. We change this A reference to now be for column B. My keyboard's being fickle. All right, so we're going to change the A reference to column B. Our output range, we're going to move over a couple to F7, F5, excuse me, and summary statistics again. So right next to it here, we get our additional set of output, and this is for the afternoon. So immediately I'm going to look at two things. The two things that I'm testing here are the means. A t-test is a test of means. So I want to look at these averages. And so initially what I see is that the average in the afternoon group is in fact higher. Now I don't know if that difference is just by chance or if it is statistically improbable that it would be due to chance. So to determine that, I have to do a hypothesis test. So the hypothesis test will compare these two means to determine whether or not the differences that there are between them are statistically significant. So although these do differ in what we would call descriptive terms, they may not differ in what we call statistical significance. So to test these, what we're going to do next is perform our t-test. Now there's a couple ways you could do this, but we're going to again use our data analysis function. So if we go to data analysis, we go to the bottom and we have t-test to sample assuming equal variances. That's the one we want for the independent sample t-test. So the first thing we need is variable 1. That's our morning group. Variable 2. That's our afternoon group. A hypothesized mean difference. So under the null hypothesis, right? Null hypothesis, the difference, mu1 minus mu2, is expected to be 0. So that is in fact what we want to put here. Okay, our alpha will be pre-specified at 0.05. That is the convention as we discussed in the announcement. And we're going to put our output right next to it and perform our test. So now we have our last set of analyses here. And so here, notice these are again the means that we're testing that we got in our descriptives. Okay, we come down, we see the variance for the groups, we see the pool variance that goes into that, and importantly here what we see is the t-statistic. And with the t-statistic, we get a two-tailed and a one-tailed p-value. Okay, so if we stick with the two-tailed test as we wrote this, we wrote these hypotheses as non-directional. So this would be the value that we would use to determine significance. And the rule is that this value needs to be less than or equal to 0.05. And this is 0.0007. So we would call this statistically significant, and we would reject the null hypothesis as a result of this, right? So we would reject this hypothesis. That is, that the difference between them is 0. We'd say, no, this difference is not 0. So we're going to reject the null, which means that we find support for the alternate hypothesis. So support for this alternate hypothesis. Now, coming back to how do we interpret this? Well, you've got to remember which group, what you're comparing. You're comparing students' exam scores in the morning and afternoon. And what we see here is that the afternoon has a higher exam average than the morning. So that's the interpretation of our finding. We would say the sample of students who took the exam in the afternoon section scored significantly higher on average, and their mean here is 84.2, and their standard deviation is 8.58. Then students who took the exam in the morning section, and their mean was 70.47 with an SD of 11.04. And so this would be our interpretation of this effect. This is what we found. And so from this, notice this is a test that is an inferential test. So from this inferential test, we are saying that this could be extended, that we would expect students in this population to do better if they take classes in the afternoon than in the morning. So yes, the differences between our two samples are statistically significant, but we believe that this represents true differences in the population at large. All right, so this would be going through, getting some of the statistics you would need, and constructing hypotheses to test with an independent sample t-test.